Every time you type on your keyboard, swipe your phone, or watch a video like this, your computer is doing millions, even billions of tiny tasks in the background. But how does it actually work? How can a box of wires, chips, and circuits turn into something that feels almost alive? Today, we'll break it down step by step. No jargon, no confusion, just a clear journey from electricity to intelligence. At the most basic level, computers don't understand words, pictures, or sounds the way we do. They only understand two things: on and off. We represent this as 1 and 0, what's called binary. Each 1 means electricity is flowing through a tiny switch, and each 0 means it's not. These tiny switches are called transistors, and a modern computer chip holds billions of them, all flicking on and off incredibly fast, creating patterns that represent data. Okay, but where does this binary magic actually happen? Inside the main parts of a computer. Let's meet them. First, the CPU, the Central Processing Unit. Think of it as the brain. It follows instructions step by step, incredibly fast, ticking billions of times per second. Next, we have RAM, or Random Access Memory. This is like your short-term memory. It's fast, but temporary. When you close your laptop, what's in RAM disappears. Then we have storage, your hard drive, or SSD. This is the long-term memory where your files, photos, and apps live, even when the power is off. Finally, there are input and output devices: keyboards, mouses, screens, speakers. They're the way humans and computers talk to each other. But the hardware is just silent machinery without instructions. That's where software comes in. The most important piece is the operating system: Windows, Mac OS, Linux, or Android. It acts like a manager, deciding what runs, when, and how resources are shared. On top of that, we have applications, the programs we use every day, like web browsers, games, or editing tools. Now, here's the interesting part. Deep down, all software ends up as binary, 1s and 0s. But we humans don't write in binary. Instead, we use programming languages like Python or C++. These get translated into machine code, which the CPU understands. Let's put it all together with a simple example. Imagine you press the letter A on your keyboard. The keyboard sends an electrical signal to the CPU. The CPU checks with the operating system to see what to do with it. RAM temporarily holds the data. The operating system tells the software, maybe your word processor, to display the letter. Finally, your screen lights up and shows an A. All of this happens in less than a blink of an eye. And this cycle, input, process, store, output, is the heartbeat of every single computer. Of course, computers today do much more than display letters. They simulate weather, design skyscrapers, and even power artificial intelligence. Modern processors contain billions of transistors on a chip smaller than your fingernail. Special processors like GPUs and TPUs can perform thousands of calculations at once. That's what makes AI, like voice recognition or self-driving cars, possible. So, how do computers work? At the simplest level, it's just electricity turning into 1s and 0s. But when you add hardware, software, and human creativity, you get the machines that run our world today. From typing a single letter to training artificial intelligence, it all comes back to that beautiful simplicity. If you enjoyed this breakdown, subscribe to Simplify, where we take the complex and make it clear.